Hello everyone, welcome to my channel. In this tutorial, we're going to talk about how to build a Shiny app that can do object detection using TensorFlow and deep learning models. Now, by end of this tutorial, you'll be able to build an application that can do something like this. So you can click the, so this is our Shiny app that's designed using the Shiny framework, and we can have this upload button to upload an image to do object recognition. So now I have the input image, and by using the deep learning model for object detection, it detected there's a potato. And this particular data set is taken from the public for grocery items. And also we can test if there are multiple items, for example, carrots, then it can also work by detecting multiple carrots in the image. Down below, there's this panel to select different images, and you can see what are the training images provided for the algorithm. So we're going to talk about the two parts. First part is how to train the deep learning model, and also how to build the application to deploy the model and to be able to do object detection. So all the codes are here hosted in this GitHub, including the Python scripts to train the model, as well as the R scripts to do the application. So feel free to check it out. Let's go to the first part, which is training the deep learning algorithm. Before the training starts, we need to mention a few things. One is the notebook is based on the previous notebook on the TensorFlow object detection from Nick Knock. And also we have taken some images from the grocery store data sets. And also this tutorial is based on the Google Colab. So you can easily click the Open Colab button and it will jump to a Colab page so that you can run all the codes here on the fly and observe the results. So here we have first imported some packages and also set the seed for random, for NumPy, and also for TensorFlow. This is purely to ensure reproducibility. We have also some configuration parameters. For example, here I'm detecting the operating system of the environment. And then based on that, I'm setting a few configuration parameters. So configuration means what is the model name? Here I'm using the SSD mobile net. So this is a particular model provided by TensorFlow Hub that can actually hit a good balance between speed and accuracy, right? Because this, for a demo purpose, we want to get results quick, but also want decent accuracy. And also this is a pre-trained model, meaning this model is trained based on some other much larger data sets, and we are importing that model, change the output to our own purpose, meaning we're going to detect only a few grocery items, but the main part of the model is going to remain the same, meaning it's going to be fixed in terms of the parameter change. So we're not going to change parameters for majority of the weights in the neural network. And we're turning its URL. So all the rest of the configuration parameters are just for logistics management. So we have the workspace, we have the place to store the scripts and different parameters. So feel free to check it out. After that, we're going to set the relevant backend management for the TF model training purpose. So we're going to first download some utility scripts from the TensorFlow model zoo. So these are the default scripts provided by TensorFlow to facilitate our training. And specifically, we're going to install the object detection library so that it makes our training easier. But the installment takes the script provided by TensorFlow, and we need to first download and then install the script. So installment actually be made easier by having this line here. So we are going to first install the protobuf compiler and then do a few things in one row. So first we're going to switch to this path and then use protoc to install the object detection related libraries, and then copy the installed library to the current path. So this is the double end sign here just to concatenate different commands together. So here you can see that we are installing and downloading and installing the package. It takes well, but eventually we succeeded in installing the library. We're going to have the verification script as well to see if it's properly installed. So if you continue with the script, you can see that there's this OK button that's actually seeing that now the object detection library is properly installed, so you can import the library to use it. Next, we're going to download and decompress the prescient model. So prescient model is pretty large, so we're going to first download it and then unzip it. So this is what it does essentially. Because we have previously provided the path, so now we just reference the content of this variable created earlier. So this is actually easier for managing if you have a lot of hyperparameters, you want to have a sort of centralized control of these parameters. Now, next is to download the training images. The training image is actually provided by the GitHub here. So we have the images previously uploaded and have divided into different categories here. So each category, for example, Apple have different images here. And also there's this XML file. So XML file is actually created it contains the information about the bounding boxes of the objects in the image. And this is done by the Python image label tool. So which is also very convenient. So let me just give you the quick link. So there's this amazing tool to help you do the image labeling by just importing image and then draw a box around the object and then give the label for that object. So this can help you quickly develop the bounding box information for the objects you need. So let's go back to the images. These are the images you can download from the GitHub link. And then we're going to also create a label map. So this label map is just to tell the algorithm that this is the objects we're interested in, and this is corresponding index, and it starts with 1. So we're going to, because Python starts with 0, we're going to do some adjustment later. And we'll also write it in the file. Next, as usual, we need to split into training and test images. So the splitting must go by category, meaning that when we randomly sample the images into training and test folders, we cannot have a situation where all the images of one particular category is sampled into just one either just training or test. So we can not let that happen, because then if all the images, for example, if all the images are sampled into test folders, then it's actually, we have no training images for that particular category. So of course, we're not able to recognize that item. So this is what the script is essentially doing, try to sample by category. So I have a few loops here. Next, after doing the proper splitting between training and test folders, then we're going to convert all this information into a so-called TensorFlow record. So TensorFlow record is a particular format that can actually accelerate the training, especially the loading and the processing handling of the images. So this is and the conversion is also made easier. There's a script to help us do this. At the end of the day, we have the training records for training the model, and also we have the test record for testing the model. So just essentially two inputs. And we're going to make a few copies of the configuration file, and also update some portions of the configuration file. Specifically, we're going to set the number of classes of the SSD model to 6. Right, so we have remember we have 6 categories, and this is because the default number of classes could be, for example, 1,000 based on the ImageNet. But now we only have six categories, so we're going to set it to 6. And batch size we can set to 4 because the data set is very small, relatively small, and also different hyperparameters you can fine tune here. So this is to control how the model will be trained or will be fine tuned. After that, we're going to write back to the configuration file. Next would be the actual training. So it actually starts by first having the script, the path in the script, and also have this command line ready by concatenating a few strings. And also this is as if we were to type the string out in a command console. So, or in a terminal if you're using Mac. So this is actually doing the actual training, also using the script provided by TensorFlow. So the training actually takes quite a while. You can enable the GPU of provided by Google Colab to accelerate the training. Now, once we have the model ready, we can have a few checkpoints, which are the sort of the different incarnations of the model where we can use to do the prediction. So in this case, I'm loading checkpoint 3, which is a snapshot of the model training process, and then use that to do the prediction. I'm also defining the detect function. So essentially, the process is quite simple. Essentially, we have the detection model. We're going to pass in the image. First, preprocess it so that it's in the relevant shape we can use to do prediction, right? By passing into the predict function, and also post-process it so that it's actually the format we need. So that's actually very simple. And we're going to test if it works on the real image. So here in this case, we are using the random choice to randomly select a test image and also give it a path and also corresponding index to see if it's correctly predicted. Next, we just pass in the path and then convert it into the NumPy image and also to a TensorFlow tensor object, and then pass it to the detect function. So it's making the detections. After we have the detections, we're going to process a bit so that the number detections and also the detection classes are in the good format for visualizing purpose. So lastly, we have this image that's showing that we have potato and it's recognizing properly, and it's indeed a potato being recognized. So here does this VCUTs, which does the visualization for us, and it's also a very convenient utility function. So by now, what we have learned is that we have actually fine-tuned the model based on the model pre-trained based on some other image, and also the algorithm itself, we can actually deploy it in the web development, web application, so that other users can use this model to predict the objects in some other new images. And this is exactly what we're going to do next. So next here, you see there are actually, let me move up a bit. So there are actually quite some files here which are in R, and this is because we're going to, let me move up a bit. Okay, so we're going to use R Shiny to do the web development, and R Shiny is actually a web development framework that's easy for you to develop web applications. And specifically, we have this UI.R, which manages all the front end, the server.R, which manages all the back end. So that's all the processing or the prediction happens actually inside the server. And also we have this global function, which is designed to manage all the global variables across the environment. So here, if you look at from the, if we begin from the UI.R, you see that this actually is very easy to understand framework, because now it uses the grid system, meaning we can decide to say, this outside bar, we want, for example, input button to select input. And this is also the input for the minimum threshold, because we want to say I only want to show items that are recognized with minimum confidence threshold of, for example, 50%. Right? So this is also possible. So all these actually pre-configured widgets which you can use to in your application, and also selection button as well. And in the main body of this web application, we can actually design to say, I want to have one row with 2 columns. So this column 1, column 1, each column has different things to show. So this is to show some text files, text, and this is to show the results of the prediction as a table. And then the next row, I'm showing the some image outputs and also some other image with the items recognized in the output as you see in the application. So maybe we move back to the let me see, to the app itself. Right. So this is the app itself, and this is exactly what we mean. So they have this sidebar, and this is the main body of the application. They will have 2 rows. So the first row and the second row, and then each row has 2 columns. So these actually are making it very easy using the grid system. So now let's continue to look at the script. So this is the server part and the UI part, and then the server part is actually also essentially what it contains is that it contains the functions used to receive the input from the user via the UI and do something about the input and then return some output. So that's essentially what it does. It's actually operating as a function. So first we receive the image uploaded in terms of the path, and then use that path to do the prediction. So that is predict class function, which we will talk about later, and then convert into a Bool format to show that result. Other things is all designed to actually show the image based on some provided functions, for example, render image or render text. So the grammar is actually very similar. Now, the global function is actually where we can, the global.r is where we can store the global functions. In this case, because I designed the framework to be self-contained, so that first we create the virtual environment using Conda, and this is enabled. This is possible because we have this reticulate package, so that we can, just as if you were using Python, we need to create a virtual environment to better manage the different logistics. Here, we're going to create an environment if it's not, if it does not exist in the default environment. And then we're going to source these Python scripts. So what this means is that we're going to take all the commands, we take all the contents from the setup.py, which is, let me just import the file. So have these different scripts here. Let me open up the setup.py. All right. So the setup.py is essentially some scripts which we saw earlier to install the object detection package, right? So this is same. I'm using the os.system to actually execute all these commands. So these actually Python scripts, and it's imported in R. So R is actually a very flexible language to actually allow different languages to be used within the R script as if they are actually written in R. So essentially what happens is that all these scripts actually wrapped as API so that it works as a function. We'll give it input and then we receive the output. In this case, it's just runs and then there's no output. But we have this image classification.py. So this actually hosts the different classification functions of the algorithm we built earlier. So here, again, these all the Python scripts, and we have defined a few functions so that it's going to be exposed to R for prediction purpose. So first we have this load model, nothing more than just load the model from the pre-trained path, and to be able to use that later. And also have this some parameters we can use and that detection model as well, and also the checkpoint. So what's really interesting is that first we have this run inference from so single image. So here, this is essentially the same script, which does the heavy lifting of detection. Then we have this final results of detection as the dictionary. And I have this predict class function, which actually wraps everything together. So give it an image path. Remember when the user uploads an image, there's this path. So this is a path passed into this function, as along with the minimum score threshold, right? So we're gonna first read that in the image and convert it into a relevant format, and also use the function earlier to run the detection. So this is the detections, and this to say if the detection score is lower than certain threshold, then I'm not going to use that. So this is to sort of customize the results and also to save that image. So this portion is actually doing the visualization, the same code, and also save that image locally. So I have a sort of handle later, and then write it back. So, and then this image is also returned to as output outside the function. So this script is actually does the heavy lifting, and it's going to be used by the application itself. So this is to convert, that's another function to convert results just for the visualization purpose. And that's it. So this is a lot of scripts, and essentially these scripts are actually loaded as we start the application. So the way to start application is just to click the run app button, and it will bring up this application so that we can use that for local testing, and also we can also choose to deploy the application via a third-party platform and expose it to other users. So others will have the link to access the application, and then use the functionality provided by this application, which is essentially do the object detection regarding the groups of items. Right, so that's it for this tutorial. I hope you found it interesting, and as usual, if you want to know more about the details, then feel free to go to the GitHub link where I have all the codes here. All right, thank you very much, and I hope to see you again.